Right, Emma, you have your hand up.
Sir, you asked me to remind you to record.
Yes. Thank you. Okay, so we've just recorded, I think. Yeah, it's recording. Okay, thank you, Emma. Right, now if I go back to sharing screen, visualizer. Okay, right, so we are going to start with question C. Okay, and Caitlin, seeing you on the line, and seeing your dad is being a lazy bum, okay, we are going to pick on you. Okay, so in this question, guys, so you've got a sequence which says 1,04 and 1,0816. Okay. Please, somebody also shout when I move it off the page, which is what I sometimes do. 1,124864. Okay. And it says find the first order difference equation. Right. So, Caitlin.
Yes, sir.
Okay, so every time you get something wrong, it's 10 push-ups, eh? Right,
Okay,
so now, for your dad, not for you. Right,
Oh,
okay, so there are two types of main sequences, well, three types really that we've been working with. Okay, I'm sure I mentioned in the videos. What do you call a sequence where you're adding a fixed amount, where there's a common difference? Ooh, pressure. Starts with an A. Arithmetic. Have I mentioned that? I haven't gone back and watched the videos again. Okay. So arithmetic. So always, guys, we're not going to necessarily say to you, okay, this is an arithmetic, this is a geometric, this is a combination. Okay. So with the key ideas is with arithmetic, okay, there's a constant difference, and you can find the difference, okay, by saying the difference will always be equal to one term minus the term before. If you keep in the same number for one term minus the term before, okay, then it's an arithmetic sequence. And if it's an arithmetic sequence, the general formula, so remember guys, there are two types of formula, general or explicit, and what they do is they generate the value of the term based on the position, okay, and then recursive or difference equations, okay, which determine the value of a term based on the term before or two terms before, okay. So in an arithmetic, the explicit formula, which you're going to use in core as well, is term n is equal to a plus n minus 1d. Caitlin, did I use that formula in the videos?
I think so, sir.
Okay, so in that formula, a stands for the first term, okay, and d stands for the difference. D is equal to the difference, okay, and n is the position in the sequence, okay. So that's your formula for an arithmetic sequence. Okay, the geometric formula, okay, sorry, my writing. Geometric formula is a term in position n plus 1, okay, or start with, doesn't matter which one you start with, guys. Okay, term in position n plus 1 would be the term before, so in that case you'd write term n, in this case you'd write term n minus 1, okay. Then you're going to add a fixed amount, whatever letter you call that, plus c or plus d, doesn't matter, okay. So it's a number, so you keep adding a fixed amount to get from one term to the next. So that's arithmetic. Okay, we're going to just remind ourselves what's going on. Okay, Caitlin, what do you call a sequence? Can you remember? Where you're timesing to get from one term to the next. You're timesing by a fixed ratio.
So is that a geometric sequence?
Oh, well done. Okay, so that's a geometric sequence. So in a geometric sequence, you're timesing by, so an arithmetic would be 2, 5, 8. And then you're adding by 3, so it's adding by a fixed amount. Okay, so that's arithmetic. Geometric, you're timesing by a fixed amount. So say you're timesing by 3, you'd have 2 times 3 is 6, times 3 is 18, right, etc. Okay, and in a geometric sequence, okay, in an arithmetic, there's a constant difference, but in a geometric, we say there's a constant ratio. And just like your difference is one term minus a term before, your ratio is equal to a term divided by the term before. So that's fixed. Okay. If you keep in the same answer when you divide out, then you're working with a geometric sequence. Okay. And if you're working with a geometric sequence, okay, if you're looking at the explicit formula, which generates a term based on its position, then Tn is equal to AR to the n minus 1. Okay? And the recursive formula is T, you've got all of this down somewhere. Tn is equal to whatever, K or R times Tn minus 1. Okay, it just means you're timesing by a fixed amount to get from one term to the next. Okay, so your first step, and then we get a combination one we'll look at later. So your first step is to say to yourself, is this arithmetic or is this geometric? So you look at that sequence, because nowhere in the question do they say, okay, you are adding or multiplying by a fixed amount. So your first thing is, okay, well, you could say, is it geometric? Is it arithmetic? Well, if you go 1 point, I don't know if you can see my screen, 1.0816, and I minus the term before, which is minus 1.04, we get an answer of 0.0416. So if I now take this and I get the same answer, then we're working with an arithmetic. But if I go 1.124864 minus the term before, I'm going that term minus the term before, 1.0816, we don't get the same number, we get something different. Okay, so it's not arithmetic. Okay, so if it's not arithmetic, we've got to check if it's geometric. So to check if it's geometric, we're going to say, okay, here's term 1, here's term 2, here's term 3. You don't have to write this down, by the way. Okay, but if I went term 2 divided by term 1, in other words, I went 1.0816. Okay, sorry, my hand. Just also yell at me if my hand's in the way, guys. 1.0816 divided by 1.04. If you go work that out, 1.0816 divided by 1.04, and I get 1.04 as my answer. In other words, I've times by 1.04 to get from this term to that term. Okay, so it'll be geometric if I'm timesing by 1.04 to get from that term to that term. Okay, so to check if it's working, we go term 3. Sorry, I'm being a shop. Okay, term 3 divided by term 2. Okay, and term 3 is 1.124864 divided by 1.0816. Okay, so you go chuck that into your calculator. 1.124864 divided by 1.0816, and hopefully I get 1.04 again, and I do. Okay, so that's 1.04. So you are constantly timesing by a fixed amount to get from one term to the other. Okay, that fixed amount is called your ratio. Okay, so now we know we're working with a geometric sequence. Okay, and my ratio, I would always focus your mind and write it down. Your ratio is equal to 1.04. Caitlin, does that make sense?
Yes, sir.
Yes, sir.
Okay, so you're timesing by a fixed amount, geometric sequence. So as I say, we're not going to tell you, hello humans, this is geometric or this is arithmetic. Okay, it's going to be the one or the other, right? And you've got to figure that out. Sometimes it's neither, but then we normally say to you, it's of the form k times tn minus 1 plus c. So in other words, it's a combination of multiplying and adding. Okay, but in this case, we've got a geometric sequence and r is equal to 1.04. So the first question then says, calculate the first order difference equation for this sequence. First order, so question 1, the first order difference equation. Do you have any idea what that means, Caitlin?
So isn't it when you use the term before to determine the next
Yeah,
term?
well done, well done. Okay, it's when you use the term before to determine the next term. Okay, so what are you doing in this sequence to get from one term to the next? I'll give you a clue here. I've highlighted it in blue.
You're multiplying by 1.04.
You are a genius. You're multiplying by 1.04, right? Okay, so that's what you're doing to get from one term to the next. So to write that mathematically, so what we're saying is go times the term before by 1.04. Okay, so you say Tn plus 1 is equal to 1. Now, if Tn plus 1 is my term, then what do we call the term before?
Tn.
What's the term? Oh, well done. Times by Tn, okay? Right? Or you could write it, if you prefer this notation, Tn is equal to 1,04. If I'm using Tn as my first term, Caitlin, well, what's the term before?
Tn minus 1.
Sure, you are really determined that your dad doesn't do push-ups. Right, okay. And then in whatever, so you use that one or that one. You don't have to write down both, guys. One or the other. Okay. So basically, either of those things are saying the same thing. The value of a term is equal to 1,04 times by the term before. That's called the first difference equation. We could also have said to you, find the recursive formula. Same question. Okay. You get the same answer. All that a first order difference equation is it's telling you that it only depends on one term before. Okay, not on two terms before. Okay, it just depends on the term before. But you'd lose a mark, Caitlin, why? If you just wrote that?
Because you didn't put in the first term.
Ah, okay. So then you also need to write term 1 is equal to 1,04. And what happens in the first modeling test you write, you all leave it out, and I take off a mark, and then you squeal, okay, and I say unlucky. Okay, there will be no squealing in this venue. It is a squeal-free zone. Right, so there is the answer for number 1. Then question 2 says, do you calculate the 30th term using that formula? Well, that's just a bit annoying because 30 goes on forever. So I'm going to change the question and let's go calculate. Choose a number between 10 and 20, Caitlin.
15.
You can't really be wrong. Okay, calculate T15. Okay, so now I'm going to use my formula to calculate the value of the term in position 15. Okay, so what we do, can you remember what I put in my calculator, Caitlin?
So you'll put in the first term, which is
well
1.04.
Okay, so you go 1.04, then you've got to press equals, kabam, press equals, now it's stored in your calculator. Okay, so when you press answer, okay, the previous answer will come up. But now you clear your screen. Okay, and the ratio was the same, 1,04, so you're going to go 1,04 times by your term before, right? And then you press equals, ching, okay, press SD, okay, and then guys, always check that you're getting it right. So that's 1,0816, okay. Now we just simply go times by answer, and we had 1, what the hell did I do? Oh man, I'm supposed to keep pressing equals. Sorry, I owe you 10 push-ups. Okay, so let's do that again. 1.04 equals, clear my screen. First term was 1.04 times answer equals, and we got that answer, 1,0816. Now I keep pressing equals. So that's term 2, right? So I'm hold up 2, I've got 2 of my figures, right? Term 3, there we go, it's 1,124864, which is what it should be. And now I've simply got to count correctly. I always write down one. My suggestion to you is you write down the first one that's not given to you. Okay, just to show the marker that you're on the right track. So I would write term 4 is equal to 1,1698586. Okay, because it's very easy to lose count. Okay, so we've got term 4 and we've got to go up to term 15. So I'm on 4. 4 is that whole thing over there, 1,16 blah 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 9856. Now I keep pressing equals. So that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I don't know if anyone's doing with me. Did you guys get 1,80094? Or are you going to just believe me? Okay, thank you. So let's just do it to 4 decimal places. So we get 1,800. We might as well do the whole thing. 94 if they don't, 3506. So that, ladies and germs, is the value of term 15. Okay. Right. Okay. Caitlin, how many push-ups is your dad on?
So I don't think he's on any push-ups.
No push-ups yet. And I'm on 10. Shut it. Okay, right. Then I'm going to keep you here. Okay. Right. Now we're going to do question 3. Is everyone happy up to there? Any questions from anybody? Please shout out with questions 1 or 2. Okay, so I've got the
So-
recursive sequence. Yeah.
If you don't write whether term 1 is a natural number or not, will you lose a mark?
No. Okay,
Okay.
you don't have to. Right, we assume it in sequences. I know Mrs. Groffley, I gave her a head slap with it because she was penalizing for that. But no, I won't penalize you for that. Just in sequence notation, anything with a T something. Okay, we always assume we're just working in the natural numbers, okay?
Thank you,
All
sir.
right. Oh, no problem. Right, so now let's do question 3. So question 3 now says, determine the general solution. Okay, so what does the general solution mean? It means the value of the term is a function of its position. So in this sequence over here, remember n, these all go together. Here n is 1, so term 1 is 1,04. Here n is 2, so term 2 is 1,0816. Here n is 3, so we end up with that, right? So n is your position in the sequence. And what an explicit formula does, or a general formula, is it generates the value of the term based on its sequence. Manually, it's far more powerful to use an explicit sequence because you don't have to find the terms before. But in computers, okay, recursive is very powerful, okay, and they can obviously compute it pretty quickly. Okay, every time you drag down a formula with Excel, that's what it's doing. Right, so now in question 3, we want the general formula. Okay. So if I want the general formula for a geometric, okay, what is the general formula, Caitlin, for a geometric sequence in terms of A and R and N?
It's Tn equals A multiplied by R to the power of n minus 1.
So annoying. Tn is equal to AR to the n minus 1 is correct. Okay, so guys, always, okay, and remember A stands for the first term and R is equal to the ratio. Okay, so in this particular sequence, Caitlin, okay, which is up at the top of the page there, what is A equal to?
1.04.
Good, and R is?
1.04 n minus 1.
Okay, so they both happen to be the same, right? So your formula, oh shit, but you guys can't see a thing. Okay, so you've got A is 1,04 because that's the first term. In this case, the ratio is the same, they won't normally be. Okay, so now I'm simply going to replace, in the formula, I'm going to replace A with 1,04. Okay, and I'm going to replace R with 1,04. Okay, so now, to go do that, I get term N is equal to 1,04. That's my A, times by R, which is 1,04. Okay, all to the n minus 1. Now that's an explicit formula because it can work out the value of term n based on what n is. Okay, so you can simply leave it like that, you'd get full marks. I could do something to make it prettier. Caitlin, what's a to the m times a to the n? If I multiply powers, what do I do to the exponents?
So you add the exponents?
Yes. Okay, a to the m plus n. Okay, right. So over here, if there's no exponent on the orange 1,04, what does that mean? To the power of what?
To the power of 1.
Okay, so if I've got the same base, so by the way, you get full marks if you stop there. That's the end of question 3. Okay, but if you want to really be impressive, okay, there are your two exponents. Okay, so if you add the exponents, if you multiply powers with the same base, and you add the exponents, what's 1 plus n minus 1?
It would be n, so.
Good. So in other words, if you really wanted to be fancy pants about the whole thing, you could have term n is equal to 1,04 to the n. That neatens it up a little bit. Okay, so that's your answer for 3. We have now gone and found the general solution, okay, for the sequence. Okay, and then the last question, and then Caitlin, you're off the hook, and so is your father, okay, is 4. Okay, now they want you to find, so you've got a formula now they want you to find the value of term 30. So what do we simply have to do?
You substitute 30 in for
Good.
n. Yeah.
Good. Because n is equal to 30, right? So n is 30, that's the position. So the value of the term in position 30, well, here's a formula, so it'll be 1,04 to the 30. And if that'll be, I don't know if your calculator can handle that. Let's see, it should be able to actually. 1.04 to the 30. Okay, and you get 3,243. So I'm going to just write the answer over there. Your final answer is, so term 30 is 3,24339,751. Actually, what I want to show you, okay, is in part 2, we worked out the value of term 15, okay, using the recursive formula. I just want to show you that term 15 using the explicit should be the same thing, otherwise I owe you 100 push-ups. Okay, so term 15 using the explicit formula, or the general formula, will be 1,04 to the 15, and 1.04 to the 15 better be 1,8, whatever it is. 1.04 to the 15, capish, plump, and we get the same answer. Okay, 1,80,093, blah, 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 blah. We get the same answer as that. Okay, and as you can realize, using explicit is generally quite a bit quicker than using the recursive model. Right, Caitlin, thank you very much for your assistance. Okay, guys, I will send you a PDF of this if you didn't get some stuff down. Okay, we are going to move on to the next sum. Okay, do we have any volunteers, or am I going to do the lucky dip on the class list? Speak now if you'd like to volunteer. Oh, we're going to have silence, I can tell. Okay, so I am going to randomly dot my pen on the list. My eyes are closed. Boom. Okay. Right to the bottom of the class it went. And we have Ine, are you there?
Yes.
Oh, unlucky. I would have kept quiet if I was you. Okay, so now we are going to do, we just did C. I wonder if I shouldn't do B with you. Okay, let's do, have you done, can we do B? Let's do B, okay? It's not a bad one. Just to make sure you, and no, I don't want to do B, I want to do A. Okay, so A, because I just want to make sure you've got one arithmetic one where you can do all of these things, because you're guaranteed in any test an arithmetic one and a geometric one. And A says the following. We've got a sequence 2, 7, 12. I would always give 4 terms. Okay, 2, 5, 7, 12. So the next one would be 17. Okay, so there's A. So step 1 always in A is identify. Okay. Who do you want to do push-ups if you get things wrong? You know, your mother or your father?
My dad, I think.
Okay. Right. Anything you get wrong, your father will do push-ups. Okay. Right. So, it says there, consider sequence 2, 7, 12. So first thing you got to ask yourself in A is this arithmetic or is this geometric? What do you think?
It's arithmetic, sir.
Good. Okay. So why? Because what are you doing to get from one term to the next?
You're adding 5.
Ah, check it you, top of your game. Okay, so your difference is equal to 5. There's a fixed difference, guys. You're adding to get from one term to the next. Okay, so we are working with an arithmetic sequence. I always make a note to myself. Okay, right. So your difference is 5. Okay, and the first thing they want you to do is get a first order difference equation. You know, is a first order difference equation a recursive formula or is it an explicit formula?
Recursive, sir.
Oh, well done, well done. Right. Okay, so it's a recursive formula. So we're going to say, let's say we start with term n plus 1. Okay, first, what's, if a term, we're talking about term n plus 1, what's the term before term n plus 1?
Tn
Good. So it's equal to Tn. And what are you doing to get from one term to the next?
plus 5.
Ah, look at you. Top of your game, top of your game. Right. Okay. Or, for those of you prefer, you could write Tn is equal to Tn minus 1 plus 5. Either way, whatever you use, you've got to write down what else, you know?
You have to say what the first term is, sir.
And in this case, what is it?
2, sir.
There we go. So, 1, 2, 3 marks for Christmas. Okay. Right, so that is the end of question 1. Question 2, they wanted you to find term 50, which means you'd have to press the calculator 50 times. Do you agree with me? That's ridiculous.
Yes, sir.
Okay, so choose a number between 10 and 20.
14.
Okay, so we're going to, instead of working out term 50, we're going to work out term 40. So, what are you going to do in your calculator?
Okay, so you're going to put the first term in the sequence n, which is 2.
Yeah, good,
Then you're going to say equals,
good,
and then you're going to say AC, and then
yeah, good.
you're going to say answer plus 5.
Ah, brilliant. Equals, right. So let's just check it's working. So we get 7, which is the next one. The next one is 12, so it seems to be working. Term 4 is 17, so I'm up to 4, right? Okay, so let's keep going. 5, 6, 7, 8, 9, 10, 11, 12, 13, 40. Okay, so I got an answer of 67. I don't know if anyone disagrees. Shout, speak now, forever hold your peace. Okay. Right, so we worked out term 14, and that was equal to 67. Okay, right. Now, okay, so we're done number 1 and number 2. Question 3, it says, are we okay with question 2,
Yes, sir.
Okay. So question 3, they want the general solution. The other way they could have asked the question is write down an explicit. The same question could have been phrased as write down an explicit formula. Okay. But now it's arithmetic. Can you remember what the formula is for arithmetic? It's got the letter A in it, it's got the letter N in it, and it's got the letter D in it.
B.
Or D or C, whatever. Okay, I'll tell you because I don't know what I did on the videos, but let's just stick to this one. Term N is equal to A, but you can also do it by inspection. Plus A. So if you want a formula, I don't like using the formula. That's the formula you can use. Okay. I'm going to do it by inspection. I don't know if I mentioned inspection on the video. Did I mention it?
I think so, sir.
Okay, so I would say, so I don't know if you remember. What am I adding to get from one term to the next?
5.
Okay, so that's always going to be, okay, the way I do it is I say, okay, I know if I'm going up in 5s, okay, that's always going to be the coefficient of n, okay? So at the moment, I've got Tn is equal to 5n, okay? If that difference there was 7, it would be 7n. If it was 2, it would be 2n, okay? Now, if I sub in n is equal to 1 at the moment, what would I get? I get term 1 is equal
to 5 plus
yeah, but what should it be though?
2.
So what do I have to do to that?
You have to subtract 3, sir.
Well done. Okay, so term n is 5n minus 3. So if I sub in now, I get 5 minus 3, which is 2. Always check it's working. So if you replaced n with 1, you'd get 2. That works. If I replace n with 2, 5 times 10 minus 3 is 7. It's working. If I put 3, 5 times 3 is 15, minus 3 is 12. And if I put 4, it's 20 minus 3 is 17. So I always check a few in my head. Okay, so that is a formula which generates the value of Tn based on its position. Just to show you, okay, you could use this formula here. So in this formula, A stands for the first term. So if you like formulas, you can go term n is equal to what's the first term? The first term is 2 plus n minus 1. What's the difference? The difference is 5. And then I go simplify. And I get term n is equal to 2 plus 5n minus 5. If I add like terms, I get term n is equal to 5n minus 5 plus 2 is minus 3. Either way, you get the same answer. It's entirely up to you guys which method you prefer, either by inspection or by the formula. Either way, it's fine. But there's your answer for question 3. Term n is equal to 5n minus 3. Okay. Right. And then the last term says, based on that formula, go find the value. Let's do what we did for the previous one. Let's do term 14. So what I'm going to do now,
You're going to put it in your calculator, sir.
Okay, but what are we going to do in the formula? What are you going to replace with what?
Okay, so Wait, sorry, so
we're using this formula, right? Term n is
yes.
5n minus 13. Okay, now we want to find term 14 using this formula. So
Oh, wouldn't you? The n's going to become 14, isn't it?
that's it. That's it. Okay, guys. So it's a substitution. Okay, the term n, the term in position n, is 5 times what position is n minus 13. Okay, that's the general formula. So in this case, term 14 will be 5 times 14. Whatever n is over there, whatever the subscript is, okay, is your position, right? So they're saying we want the term in position 14. Well, a term in position n is 5 times its position minus 13. So this will be 5 times its position, which is 14 minus 13. And if it's not 67, I'm in trouble. But 14 times 5 is 50, 90. And 90 minus 30, am I right? 5, 50 plus 20, 70. Oh, let me just use my calculator. 5 times 14, 70 minus 13. I'm getting nervous here. Why did I get 57? 5 in minus 3. Where did the 13 come from? Whew. Okay, auto recovery, no push-ups. Okay, the formula was 5n minus 3. So it's 5 times 14 is 70. 70 minus 3 is 67. Okay, so term 14 is equal to 67, which is the same thing as I got that method over there. Okay, and does that make sense?
Yes, sir.
Sir,
Well done. Yes.
I have a question, but I'm sorry, I'm jumping to somewhere completely different.
So which question then?
So in the group, you said that we must read these pages before the lesson.
Yeah.
I was looking at example 12, the solution for A, and I was just a bit confused because I thought you would have to substitute the 5 into the bracket, if that makes sense. So would this be an excessive answer?
So this over here, okay, this is a bit of a weird way of asking it, okay, because they don't give you the first term of anything, so we can't go into much detail. So what do they say? They want the general solution. So you're adding 5, right? So I'm going to write it like this rather. Can you see my book? Who am I speaking to, by the way?
It's Rory, sir, and yes, we can see your book.
Okay, so Rory, yeah, I wouldn't use their language, quite honestly. What I would do is I'd say, okay, what is this sequence saying, Rory? You've got to do, what do you do to get from one term to the next?
You've got to add 5.
Okay, so are we arithmetic or geometric?
Arithmetic.
Okay, so you're adding 5. Okay, that's an arithmetic sequence. Okay, often the textbook, I use different notation to the textbook because I want it to link with core. I don't know why they do this sometimes. Okay, both are correct. So it's an arithmetic sequence and your difference is 5, right? Okay, it's a good question, by the way. Thank you for asking it. So if you want to use a formula, let's stick to this formula, this notation, guys. Tn is equal to a plus n minus 1 d. Okay, right, and the best you can do in this case, because they don't give you n, okay, and they don't give you, we just know the difference, right? So the best I can do is say that term n, so if you wrote it like this, is equal to a plus n minus 1 times 5, that's perfectly acceptable. It means exactly the same thing as this. N minus 1, sorry. Okay, it means the same thing as that over there. You with me? Okay.
Yes,
Whether
sir.
you use the notation A or T1 doesn't matter. Okay. So then likewise, in this one over here, sugar. Hang on. Let's move this over a bit. Okay. Right. In this B over here, Rory. Okay. So what are you doing here? You multiplying by 1, 1, 2, right?
Yes,
So,
sir.
so is it arithmetic or geometric if you're multiplying by a fixed term?
It's geometric.
Okay, and your ratio is 1, 1, 2. You with me?
Yes, sir.
And the general formula for an arithmetic, which we're going to use, is Tn is equal to AR to the n minus 1. Okay, where A stands for the first term, okay, and R stands for the ratio. Once again, in this particular example, we don't know the first term, so we can't fill that in. Okay, but we do know the ratio, so I can replace the ratio with 1, 1, 2, n minus 1. So once again, if you left it in this format or in that format, it doesn't matter. Same thing, okay?
All right, thank you, sir.
Okay, thanks for the question. Right, guys, how are we doing for time? What time does this lesson end? 11:45. Okay, so let's do question D, number 2. Right, Rory-san. Okay, you made the fateful mistake of asking a question, and now I'm keeping you on the line. Right, and we're going to do D2, which says, go find sorry, COVID. Determine the general solution for the following first order difference equations and hence calculate the term indicated. Okay, so we've got in question D2, you've got term n is equal to Tn minus 1 minus 4. Okay, and they tell you go find it's fine, T800 given that term 1 is equal to 1. Okay, so we're going to do two things. Okay, first of all, we've got to find the general formula. Okay, but what I recommend, Rory, is before we find the general formula, I generally just get rid of my recursive sequence and I write out the sequence. Okay, so Rory, in this sequence, what's term 1 going to be? Well, term 1 they gave us, sorry, it's 1,
Yeah.
right? Okay, so what will term 2 be?
It'll be -3,
Good, and the next term?
-7,
Okay, and let's do one more.
-11.
I wouldn't write it out like that. I would just say this. Your sequence is 1, -3, -7, -11. Right. So Rory-san, are we working with an arithmetic or a geometric sequence?
Arithmetic, sir.
Good. So it's an arithmetic sequence. I'll make a note to myself. Okay. And now, what's your difference, by the way?
-4 is the difference.
Okay, so now you've got a choice. You can either go find the general formula by inspection, I'll do them both ways again, or by using the formula. What are you going to do one with me? Which one do you want to pick, Rory? Formula or inspection?
The formula, please.
Okay, so what's the formula now for an arithmetic sequence?
Tn equals A plus, in brackets, n minus 1 and then D.
Good. So in this particular case, what's A?
A is 1.
Good. So term n is going to be equal to 1 plus, I'll replace A with 1. Okay, so A is 1. Okay, n, we want n to stay there because we're looking for a general formula. And what's D?
-4.
Okay, make sure that's in a bracket, otherwise it means -4, not times.
So
Right, so go neaten it up, and I get 1 plus -4n. Okay, so it's going to become 1 minus 4n plus 4. Okay, so your final answer is -4n plus 5. Okay, check if it's working. Okay, if I sub in 1, I should get an answer of 1, right? So -4 times 1 is -4 plus 5 is 1. If I sub in n is equal to 2, I should get an answer of -3. -4 times 2 is -8 plus 5 is -3. And I'll take one more. If n is 3, I get -12 plus 5, which is -7, which is what I should get. So that's working. For those of you who do it by inspection, all you do is this. You say, what am I subtracting by? What's my difference? Okay, my difference is -4. So whatever the difference is, that'll always be the coefficient in an arithmetic. So I've got -4 in it at the moment. If I sub in 1, I get -4 times 1, which is -4. But what should I get? I should get +1. What do I have to do to -4 to get to +1? I have to add 5. So I get term n is -4n plus 5. So either way, that's your formula. Okay. Right. Okay. Then, okay, so we've got a formula now, Rory-san, and now they want us to find, okay, term 800. The term in position 800, what is the value of that going to be? So what are you going to do, Rory-san?
you substitute 800 where n is written.
Good. So you're going to write T subscript 800. I'm going to replace n over here with 800, the term in position 800. So it's negative 4 times 800 plus 5. Okay, and we lob that into our calculator. Negative 4 times 800 plus 5, capish, and we should get negative 3195. Okay. Right. Rory, would you like to volunteer somebody for the next question?
Kia can go soon.
Okay. All right. I'm going to randomly pick my pen. Okay. Tando, are you there?
Yes, so I'm here.
Are you dreading this, Tando?
Yes, sir, I kind of
Who's going to do push-ups for you? Your mom or your dad?
My mom.
Okay. So if you get anything wrong, your mom does push-ups. Right. Term N, we're doing question 3 of D number 3. Okay. So it's 1, and they tell you, they give you the recursive formula. Okay. And they want you to go find term 15 if T1 is equal to 5.
T1.
Okay.
Okay.
So they give us that. So the first thing I would do, Rory Sang, is I'd actually write out the sequence. Okay. So the first term, okay, they tell us, I'm just going to write down the sequence. The first term, oh, let's just do this, I'll explain it once. So T1 is 5, right? What I do, according to this formula, to get a term from the term before, what I do to the preceding term?
You have to multiply by 1,03.
Good. So term 2 will be, you don't have to write any of this down, will be 1,03 times 5, right? Which is 1.03 times 5, and we should get 5,15. Okay? And then what I have to do to 5,15? I also have to times it by
Multiply by 1,03.
Okay. So you don't, as I say, you don't really have time normally to write this out. I'm just explaining it. And times by 1,03, and we're going to get 5,3045. So if the question said go write down the sequence would be, okay, it's a geometric sequence and it's equal to, okay, the first term is 5, the next term is 5,15, the next term is 5,3045. So you don't have to do this, but this is how I generally start the question. Okay, and now I'm just going to work with that. Okay, well, I'm going to use this a little bit as well. So now they say to us, they want the general formula. Yeah, find the general equation. So, first of all, in this geometric sequence, Tando, what's A? What's the value of the notation we use for little a?
It's 5.
Good. What's the ratio?
1,03.
Good. Okay, 1,03. And can you remember the general formula for a geometric sequence?
For
A.
Tn is equal to Tn is equal to a multiplied by r to the power n minus 1.
The moment saved, you saved her. Tn is equal to ar to the n minus 1. Good. Okay, so now, okay, I want the general formula, so I leave n in there. I replace a with 5, and I replace r with 1,03. Tando, can I times those two numbers together?
5 times 1.
You can't times them together. Why can't you times them together?
No.
Because they've got different exponents. You with me?
Oh yeah.
Okay. So if I said to you this, I don't know, 2 to the 1 times 5 to the 4, I can't go say that's equal to 10. That's not equal to 10 to the 4. Are you with me? Okay, there'll be a completely different number to that. So just be careful. So I'll ask that question. That's the end of the answer. That's your answer. That's the general formula. Okay. You can't go times anything together. Okay. Right. So there's your general formula. Okay. And now they said to you in the question, they want you to find T15. Okay. So what am I going to do, Tando, in order to find T15?
You have to substitute n with 15.
Good. So term 15 is going to be 5 times 1,03 to the 15 minus 1. In other words, it's equal to 5 times 1,03 to the 14. Okay, right. And now, if you shove that into your calculator, 5 times 1.03 to the 14, you get an answer. I get 7,5629. 7,56.
Yes, sir. I got the same answer.
You get that as well? Okay.
Yes.
Let's just do it to 4 decimal places. Okay, are we happy with that?
Yes, sir.
Okay, guys, I think some of you might have to go. I'm going to do one more sum with you just because I'm worried that you're going to struggle. I'm going to do F quickly with you. If you want to stay, you can stay. If you have to go, okay, I'm recording it. Okay, right. So I'm just going to do F with you. Okay, but if you have to go, you can go. Okay.
So,
Any volunteers? Yeah.
sorry, I'm not volunteering. I just have a question.
Who is this?
This is Ines, sir.
Okay, now, yeah.
So, my friend Ella, who's in the class, said messaged me to say that she doesn't think that she's in the emails because she hasn't been receiving the call invites.
Okay, I'll double check Teams. Okay, and I'll
Okay.
add it to Teams if she's not there. Okay, well, I apologize. Right. Okay, any volunteers for F, or should I just, if there are no volunteers, I'll quickly do it with you. Okay. So guys, this formula in F, okay, they say to you, you never have, we'll always give you this formula in the question, okay? So this is for one of those ones where you're combining a term with the term before, okay? So we're combining multiplication and addition. So in other words, Tn is equal to 7 times Tn minus 1 plus 5, and is an example of what you're working with, where you're timesing a term by 7 and then you're adding 5. So K is the number you're multiplying by, okay, and C is what you're adding then. Okay, so it's one of those ones with a combination. Okay, and this is a recursive formula. Okay, so that's your recursive formula. To convert one of those into an explicit formula, in other words, where we can, or a general formula, one of the formulas where we term n is a function of n, okay, so there's a formula that does that for you, okay, and it's given over here. We will always give it to you in the question, which says Tn is equal to term 1 times k to the n minus 1 plus c. I mean, I don't know this formula. K n minus 1 over k minus 1. Right. So that is the formula we're going to use. So in this particular, so this is the explicit formula. This over here is in recursive form. Okay, that's the recursive formula over there. Okay, right. So now, in this particular question, they give us a sequence. They say it's 2, 7, 22, 67. Okay. And the first thing I've got to do is I've got to find the value of K and C. In other words, basically, I've got to find the recursive formula. Okay. So you're saying to yourself, what am I timesing by and adding? Okay. So you're timesing and you're adding fixed amounts. Okay. So you could do it by inspection. Okay. This one's not so bad to see. Okay. If you check, you're timesing by 3, you're adding 1. Timesing by 3, adding 1. So if you just did it by inspection, it's fine. But let's say you forgot how to do it by inspection. Okay. Then you'd go 2, 7, 22, 67. Okay. So what I do is I say, okay, we're adding 5. It's easier. This is an easier method than using simultaneous equations. Then you're adding 15. Then you're adding 45. And then you say to yourself, what am I timesing by to get from one term to the next? Now I look at this pattern. And to get from 5 to 15, you're multiplying by 3. And from 15 to 45, you're multiplying by 3. Okay? So this thing over here, whatever that number is going to be k in this sequence. Okay? So at the moment, we've got term n. I replace k with 3 is 3 times term n minus 1 plus c. Okay? So that's where I'm up to at the moment. Okay, so now you could just use the sequences to check. So if I wanted term 2, and that's term 1, term 2 would be equal to 3 times term 1, which is 2 plus c, right? But you can see that term 2 is 7 is equal to 6 plus c, so c must be equal to 1, but you don't have to show any of that, you can just do it in your head. Okay, so you can go 3 times 2 is 6, what do I have to do to get to 7? Add 1. 7 times 3 is 21, what do I have to do? Add 1. So there you get your answer. Term n is equal to 3tn minus 1 plus 1. Right, so now in this notation over here, k is the number you're timesing by, which is 3. And in this notation, c is what you're adding, which is 1. So k is 3, okay, and c is equal to 1. Right. We also know the value of, we're going to use this formula over here, and we need the value of term 1. So term 1, okay, is equal to 2. So now I've got all three of those. Okay. So now, guys, I'm going to take those three values. K is 3, C is 1, and T1 is 2, and I'm going to plug them into this formula. I'm not going to write that formula out again. So the first thing I'm going to have, term n is equal to, well, the first thing I have here is term 1, which is 2, times by. Then I have K over there, and the value of K is 3. Okay. So if they ask you, sorry, I'm going to do this first. If they ask you for the general formula, this would be the answer. They didn't ask us that, they asked us straight away for term C. Okay, but I'm going to write down the general formula first. Okay, so the general formula would be 2 times 3 to the n minus 1, because I want a formula which determines Tn where all you have to know is n, right? Okay, so I'm up to there on the formula, plus C, which is 1. There's C, times K, which is 3. Okay, there's K over there, to the n minus 1, minus 1, over, this was K again, all over K minus 1, so all over 3 minus 1, which is 2. So if they ask you for a general formula, you'd have to find K, C, and T1, and then you'd plug it into, and they'll always give you this formula over here. You don't have to know that. Okay, so that would be your general formula, guys. So if they ask you now, in this question, they ask you for the value of term 15. So term 15 is going to be 2 times 3. All I'm going to do is replace, every time I see an n, I'm going to replace it with 15. Okay, so it'll be 2 times 3 to the 15 minus 1, which is 2 times 3 to the 14, plus, that 1 can disappear. Okay, and then I've got 3 to the, what is the n? 15. So 3 to the 14 again. Okay, there's n, that's n minus 1. Okay, minus 1 all over 2. And then we just plug that into your calculator. Sorry, I went off screen. Okay, so term 15 is going to be 2 times 3 to the 14 plus fraction 3 to the 14 minus 1 all over, just doing it over here, all over 2 equals 2, and you should get 1195742. Okay, and that's the value of term 15. All right, guys. Okay, I hope that makes sense. Okay, I will send you a PDF of this. Okay, and that's that. All righty. Okay, is anyone still there? No.
Yes, sir.
All right. Okay, bye, guys. Rory-san, can you stay for a minute?
Yes, sir.
Bye, sir.
Hang on. Hang on, I want to stop the recording at least. Wait. Stop recording. Okay.